So here in this lesson, lesson 14, we're talking about the first derivative test. All right? Someone showed up yesterday kind of scared that we were having a test. That happens every year whenever I put this on the Sunday Post. No test today. We're learning about the first derivative test.
So Patrick.
Okay? No, I won't say who it was. All right. But here's the idea, okay? And we've already kind of seen this, but we've only seen this basically in the context of rectilinear motion. We want to generalize kind of what we observed there with movement to the right and movement to the left, and generalize it for all functions, okay? So let's look at this here, okay? And that is, if f prime of c is positive, then f is increasing in a neighborhood of the point cf of c. Okay, so if we have this point c, okay, we have this point c, and we see that the derivative is positive there. When we talk about in the neighborhood, basically, you know how when we found the zeros of our velocity with rectilinear motion, that divided the whole thing up into intervals, okay? Basically, the neighborhood is that interval, okay? So, in the interval that c falls within, it's going to be increasing, okay? Then, if f prime of c is negative, then, like at this point here, then our function is going to be decreasing in the neighborhood of the point cf of c. And then we have the third one option here. If it's not positive, it's not negative. If it's 0, this is really what the first derivative test is all about. And that is, we may have a relative minimum, a relative maximum, or what we call a plateau point. Okay? Now, what you see here on this parabola is a relative maximum. Okay? Now, there's a distinction that we need to make here. I have a side note over here. Okay? And that's this diagram here. The difference between a relative minimum or maximum and an absolute minimum or maximum. Okay? We could be talking about a particular interval, like I have this function drawn here. Okay? So in this interval, you'll notice here I have 3 different points labeled as relative max or min points, because if I were to draw the tangent lines here, they would be perfectly horizontal. The derivative would equal 0. Okay? So those are 3 points where f prime equals 0. All 3 of them are relative max or min points in this case. I'll look at a plateau point in a sec. Okay? However, on this interval, we can identify what are the absolute max and absolute min. Okay? So what's the difference? A relative max means that around that location, it is the highest point. All right? In other words, I am increasing as I approach it, and I am decreasing after that value for a max point. Okay? Notice both of these. The absolute max, I'm increasing, then I'm decreasing. For an absolute min, I'm decreasing as I approach it, and then I start to increase afterwards. Okay? Those are relative max or min points. Okay? The absolute max or min is either going to be one of those or possibly an end point. Okay? in this case, the end point over here on the left happens to be the absolute min, but over here, this relative maximum also happens to be the absolute maximum on this interval. Okay? Does that make sense? Okay? That is an important distinction. You have to make sure you make in your head the difference between absolute and relative.
So if the relative minimum there was lower than the absolute min, would that be the relative and the absolute, or no, because it's not an endpoint?
No, it would be. If this went down way down here, then yeah, that would be a relative min and the absolute min. Just like this one over here is a relative max and an absolute max.
And then would that be a relative min, or would that just be nothing?
No, this would be nothing. Just like the endpoint over here on the right, we don't call it a relative min or anything because it's just the end of our interval. Okay, really good question though. Okay, so we also see here, we see a case where, notice, we're increasing over here, so that means our derivative must be what? Positive. Okay, then we reach this point where the derivative equals 0, and it's kind of a weird instance here because notice the tangent line actually passes through the function. Okay? But what's happening here is we're increasing and all of a sudden we stop for a moment, but then we continue to increase. Okay? So the derivative still equals 0 here, but we do not have a change of sign. Okay? Now let me just illustrate what we're talking about here. If I were to draw a sign diagram for these two graphs, okay, let's say that this happens at 2, okay, my derivative would be positive, then 0 at 2, and then negative for this one. But over here, again, let's assume this happens at 2, my derivative is positive, then 0, and then it continues positive. All right? So what we have over here is a relative max, and what we have here is what we call a plateau point. A plateau is a geography term. It's just a elevated but level part of ground.
That'd also be
Okay.
absolute max, I think.
In that case, it would also be the absolute max, yeah. Okay? So, let's look at these here real quick, okay? And let's sketch a line graph for the derivative. Okay? So here we're going to do f prime. Where does f prime equal 0 in this case?
2.
At 2. Okay? And to the left of 2, what do we know about our derivative? It's going to be positive. Okay? Our derivative is going to be positive. If you're not sure, draw a tangent line. If it's going uphill, your slope is positive, right? Okay? And then on the other side of that, our derivative would equal, or would be, negative. Okay? So there we go. How about this second one?
2.
Okay, it's 0 at 2. What's probably happening, given how much it flattened out here?
It's like an x to the 10th or something.
Okay, it might be a higher degree. It might be a multiple root. Okay, just like you guys graphed like x squared as opposed to x to the 4th or x to the 6th. You come down, you hit the 0, but it flattens out more. It's the same idea here. The derivative will have a 0 at 2, but it might be a second root or something like that. Okay? But as we approach 2 from the left, what's our derivative?
Negative.
It's going to be negative. Okay? And as we approach it from the right, or as we go past it to the right, our derivative is positive. Okay? And then for 3, again we have at 2, we have a 0. The derivative to the left of that is going to be positive, and to the right it's positive. Okay? So, this right here, we can see all 3 different cases. Alright, take a look up here, guys. All 3 different cases. If we're changing from positive to negative, what do we have at that point? A relative maximum. Okay? This is a relative maximum. Okay? If we're changing from negative to positive at that point, we have a relative minimum. Okay? And if there is no sign change at all, that's a plateau. Okay? And guys, really, that is our first derivative test. Okay? The first derivative test. Let me go ahead and state it down here explicitly. Okay? Now, here's a little thing with AP Calc, all right? If you are asked to prove or to show that there is a relative max or a relative minimum or a plateau point at a specific point, you need to use the first derivative test, or when we get to it, the second derivative test. Okay? But our first derivative test okay, if f prime of c equals 0, okay, first of all, if, and I should say, if f prime changes from positive to negative, then there is a relative max at x equals c. Okay? Secondly, if f prime changes from negative to positive, then there is a relative min. At x equals c. Okay? Or thirdly, if f prime does not change signs then there is a plateau point. At x equals c. All right? That is our first derivative test. If you are asked to determine whether a point is a max or a min or a plateau point, you need to use this test. Okay? Again, remember AP Calc is a lot about just communication. All right? It's not enough just to draw the sign diagram. Okay? You need to draw the sign diagram and then state, because we're changing from increasing to decreasing, okay, which is what's happening. If f prime is changing from positive to negative, then the function is changing from increasing to decreasing, okay? If f is changing from negative to positive, then the function is changing from decreasing to increasing, okay? You need to state that because the function is changing from increasing to decreasing, we have a relative min at this point. Okay? So again, communicate. Alright? Just to illustrate this in a little bit different way, let's look at 13 here. Okay? We have an xy plane at -2 and at 1 and at 3 we have places where the derivative is 0. Okay? So let's look at what's happening here at -2. What is that point going to be? It's going to be a relative maximum. And here's where you guys can even mark in your diagram, rather than just a plus or minus, this is going to be increasing to here, decreasing to there. So we have a relative max at -2. So if you're asked to sketch something like that, you can put that max wherever you want, but it needs to be increasing as we approach it, and then decreasing afterwards. Okay? What is at x equals 1?
Minimum.
A relative minimum, okay? So, because it was decreasing and now it's going to be increasing. So, let's put that down here. It doesn't have to be even below the x-axis, but let's just do that. Now it's increasing a little bit. What do we have at 3? A relative max, and then it goes to decrease again. So let's put the relative max right here. And there you go. Okay? Now, there's an infinite number of possibilities here. I mean, I could have made my maximum here, my minimum here, and my maximum here. You know, and I could have had it look something like this. Alright? Both of those would be valid sketches for this information. Okay? So, there's more than one answer here. Okay, so that's our first derivative test. That is how we determine whether a function is increasing or decreasing. And that's also how we determine whether points are max, min, or plateau points. Okay? All right.